Okay, so continue our study of absolute values. In this section, we're going to talk about absolute value inequalities. So we can actually graphically represent what's going on in these situations in kind of a nice way. So let's say your original expression was the absolute value of x is equal to 7. You're trying to find the x values that satisfy that. Well, we jumped right to the solution in that kind of situation. X is equal to negative 7 or 7, right? That one is a little bit simplistic, but you have a graph for it nonetheless. So we could actually graph in negative 7, and we could also graph in 7. So we don't really get intervals, but I mean, well, you do, but it's kind of two trivial intervals. Okay, but what happens when you have inequalities like this? Well, when you drop the absolute values, you will get an expression like this. So if you say the absolute value of a is less than 5, well, then that means that a has to be between 5 and negative 5. Right? So the graph for that would look like the following. So negative 5 to 5. Okay, and now we have an actual sort of interesting interval. And those would be the a values that satisfy that, right? So for example, if a was 4, if you take the absolute value of 4, that's 4. But if you take the absolute value of, say, negative 4, well, then you get 4, but that's still less than 5. And once you're outside of these regions, you no longer are going to satisfy that, that inequality. But what happens in these situations? Let's say that you want the absolute value of y to be greater than or equal to 4. Well, you could probably think of the positive examples, right? So 4 and larger would satisfy that. So 4 and larger would satisfy that inequality, right? Anything that's 4 or bigger, like 5 or 6, you take their absolute value, well, they're bigger than 4, right? Well, what else, though? Well, certainly if I take the absolute value of negative 4, that would solve this. So negative 4 is also going to be included. But which direction are we going to go? Are we going to go to the left or are we going to go to the right? Well, if you go to the left, then you're talking about negatives of higher magnitude, right? So for example, negative 5. And the absolute value of negative 5 is 5, and 5 is bigger than 4. So we want to actually have this portion of the graph, right? So that's how you can explain what the compound inequality solution would be graphically. But how do you jump right from this to the algebra? Well, the way that you do that is you drop the absolute values for the positive part, right? But then you're going to have to reverse the inequality for the other part. Okay. But there should be a negative here. So that's a small typo. There should be a negative there, right? So y is less than or equal to negative 4. Okay? Or y is greater than or equal to 4. All right, so I'll fix that typo in the well, it'll be right here. Okay, so just keep that in mind. You don't actually have to graph this out. We can actually just jump right into it. So if you have a less than, you can get rid of the inequality, or the absolute value, sorry, and you can just go to the expression is in between the two ends, right? So the negative, like when it's equals, right, we have the plus or minus. Down here, it is sort of like you have the plus or minus, but what happens changes, and it depending on if it's less than or greater than. So when it's less than, like this, you drop it and you put it between the negative and the positive. When you have to drop it and it's a greater than, well, you have the positive portion, which is the same, but then the other one is you're going to have to change the inequality, right? So it'll be a less than or equal to the negative version. So that's the more tricky one. But let's look at some examples. Okay, so here's some examples. So we want to solve and graph the solution set to each of the following inequalities and also write the solution in interval notation. So if we have absolute value of x is less than or equal to 7, okay, so when you're dealing with less than or equal to, well, certainly x being less than or equal to 7, some of those x values are going to satisfy this, but you don't want to go too far. So when it's less than, you're going to bound it by the plus and the minus. Okay. If you ever forget, if you're making a mistake here, you can just pick a test value. You know, an example of a value in here. Well, if you graph this thing first, you know, so let me change the color real quick to purple so we can get a real number line here. And let's graph this. So, okay, so we're going to have our -7 and +7, and the x values are the ones that are in between these two. Okay, so if you're ever worried, just pick something that you think is a possible solution. So for example, isn't 0 between these two? Well, absolute value of 0 is definitely in here. Okay, now what's the interval notation? Well, the graph will help us out there. So we can convert this to the interval from -7 to 7, and we'll put the square brackets there because we're including those values. Okay, now what's going to change in this situation? So I want absolute value of x to be greater than 4. All right, so again, one part of the solution will be to essentially drop it. Okay? But we are also going to have or the other case. So we're going to have to talk about the extreme of the negative. So we will have a -4 and it'll be compared to x, right? But what's going to change is that inequality has to change. Okay? So just, I mean, I'm not a fan of memorization, but if you do memorize this, it'll help you. It'll be a little bit faster for you. But if you do forget, you can always do the testing of a value, like I was saying. Okay, so let's graph this. Okay, so we still have a real number line. Let me graph the real number line. Okay, let me switch back to a red color. Okay, so then we have the first one here, x being strictly greater than 4. That's going to be an open circle because we're not including 4, and values are larger, so it'll look like that. Or -4, not including that, but less than that, so it'll look like this. Okay, and again, if you're concerned, just pick some test values in both of these portions and see, did I get that right? Well, what's something that's over here? Well, -5 is over here, isn't it? So if I plug in -5, the absolute value of -5 is 5, and yes, that is bigger than 4. And over here, I could pick like 8. Absolute value of 8 is 8. That's bigger than 4. So usually the positive part is pretty quick to understand, but what to do with this negative? Well, there it is. And how do we represent this in interval notation? Well, we're dealing with a union here, right? Or, so we have -infinity to -4, open parentheses, and you're going to use the union symbol for the or, right? And from 4 to infinity. And that would be the solution in interval notation. So let's look at solving some of these. Okay, so for example, let's say that you had something like this. Well, we have an absolute value involved here, so it's not just an ordinary inequality. So we're going to have to do a little bit of work, but we want to isolate that, just like we did before when we had, well, just like we did before in the previous section. So subtract 5. So then we'll have absolute value of t, left on the left, this will cancel. Absolute value of t is greater than 8 minus 5 is 3. Okay, and then now, how do we continue from this point? Well, we're talking about a greater than, so we're going to have t is greater than 3, or t is less than -3, right? So when you're talking about greater than, that's when you're going to get the splits here. Okay, so we could graph this. Oops, let me switch to purple for the real number line, just so I'm a little bit consistent. The picture looks kind of nice. Okay, so we have our real number line. Switch back to a red. Okay, so t is going to be greater than 3. We're not including that in this case. So over here, and t is less than negative 3. Oop, label that. So negative 3, also not including that. And we get this. So we see that we are getting a union. There is no overlap in this situation. So in interval notation, from negative infinity to negative 3, union 3 to infinity. Okay, so continuing. Well, here we have an interesting situation. So here, this is kind of an interesting situation because we have this negative over here. If you actually think about it real quick, you can actually see that this is always going to be true. Because when you take the absolute value of something, what do you get? You always get a non-negative, right? So certainly, whatever y is, no matter what y is, if I take the absolute value of it, it's going to be greater than or equal to 0, right? For all real values y, you saw this in the book, the absolute value of y has to be greater than or equal to 0, right? If you pick a positive, it's going to stay the same. If you pick a negative, then you're just going to pick the positive portion of it. The only way that it is 0 is if it is 0, right? Okay, so what I'm saying here is this is always, here's solution 1. This is always, if I could spell, always true, right? So no matter what y I pick there, I know the absolute value is greater than or equal to 0. So certainly that is strictly greater than negative 3, right? So what you could say here is, that's your interval. That's your solution, or you could just write all real numbers. That's another way of writing it, remember. Okay, now solution 2. So if you didn't notice that, it's fine. You can still solve this, right? Using our method, you have this. So dropping the absolute values, you would have y is greater than negative 3, or y would be less than the negative part of this, which would be 3. Now, if you graph that real quick, you're going to see, oh, well, I'm still going to get this answer, actually. So let's do that real quick. So if you draw this on a real number line, the two sets, what happens? So we have y is less than 3, so that would be here. Y is less than 3, or y is greater than negative 3. Now remember, when you're talking about or, you just want to be in one or the other. You see that every real number is in this red portion here. So the union is this, right? The union of those two is the whole real line, right? This is the union. So you're going to get the same solution, same answer. As a side exercise, what if absolute value of y was, let's say that it was less than negative 3. Well, do you see that that's a problem? Because the absolute value of y is greater than or equal to 0. So there is no way that could possibly happen, right? There's no way that I could take the absolute value of something and then be smaller than a negative 3, because I'm not even going to be negative, right? And if you try to solve it the same old method, this is impossible. So solution 1 to this thing, no solution, since absolute value of y is definitely non-negative, greater than or equal to 0. So you would write the empty set, right? Solution 2, you'll get the same. When I say solution 1 and solution 2, I just mean just solve it a different way. So the second way is you could use our same old method. This is a less than, so you'd have this. So this would convert into this expression, right? You would drop the absolute value, but then you'd have less than negative 3, but then y would be greater than the negative of negative 3, which is positive 3. But look at this. This doesn't make any sense. This is impossible, right? Not possible. You can't find for me a y value that's that is bigger than 3 but smaller than negative 3, right? That doesn't make any sense, right? This would actually say 3 is less than negative 3. That doesn't happen. So this is nonsense, right? So just maybe, yeah. So empty set, right? Not possible. Okay, so continuing on to this. So we have absolute value of x plus 4 strictly less than 2. So if we want to drop the absolute values, right, we'll still be less than 2, but then we have to be greater than negative 2. Okay? And then we want to isolate this x. So we're going to have to subtract 4. This is compound inequality, so we're going to have to subtract 4 from all parts of the inequality. So this will be negative 6 less than x, right? And these 4's cancel. Less than negative 2. And so that is our solution. But if we want to graph it and get the interval notation, let's do that. So the graph, negative 6, negative 2, and then we're considering all of these x values that are between those two, right? So the interval notation would be negative 6 to negative 2 using open parentheses, right? So that would be your solution. Continuing on, we have absolute value of 5y minus 1 is greater than or equal to 4. Okay, so one of the solutions is going to be 5y minus 1 greater than or equal to 4. Or what else are we going to have? Well, we're going to have 5y minus 1 less than or equal to negative 4. Okay, and then how do we proceed? Well, you're just going to solve both of these compound inequalities, and then we'll see what the solution gives us. Okay, so we'll add 1 to both sides, and then we'll have 5y greater than or equal to 5. We have to divide by 5. It's not negative, so we won't have to swap the inequalities, so y is greater than or equal to 1. So that's one of them. Let's see what happens to the other one. So we add 1. We'll have 5y is less than or equal to negative 3. We got to divide by 5. And then we will get our solution, negative 3 over 5. And then let's see what happens when we combine these. So let's draw, I know I didn't switch the color last time, but let's just do that to be consistent. Hopefully it's a little easier to see these graphs. Okay, so we got a real line here. Switch back to red. So y is greater than or equal to 1. What would that look like? So that's going to be a filled in circle, 1 greater than or equal to. And then the other one, filled in circle, negative 3 over 5, and less than or equal to that. So you see that there is no overlap here, but this is a union. So we're going to have negative infinity to negative 3 over 5 union 1 to infinity. And that would be our solution. Oh, whoops, actually, you know what? We accidentally used closed parentheses here when they should have been, open, and they should have been closed, right? So let me just change that real quick. Sorry about that. So we will change these to be closed parentheses. Okay, so this was a negative 3 over 5, negative 3 over 5. Sorry about that. So closed, closed. Yeah, so always double check that what you're writing here matches your graph. So I guess I'm guilty of that, right? So closed, closed. Okay, so continuing. Let's see what we get. Oh, okay, so it's getting a little bit more complicated. All right, now before you do this multiplication, we want to get rid of the absolute value first. Okay, it looks like there's going to be fractions involved. A standard thing you might want to just do is multiply by the least common denominator, but let's get rid of the absolute values before we do that. So we'll have 4x minus 3 over 2. Getting rid of this less than or equal to 1/3, right? So if I drop that, well, certainly it looks like some solutions are going to work. I'm less than or equal to that. But you want to make sure that you don't go too far less than or equal to. It's got to be in between these two. Okay, now at this point, let's multiply this whole thing by the least common denominator. So least common denominator when we have 2 and 3 is a 6, right? So I multiply by 6, I'm going to get rid of those fractions. So I will have negative 6 over 3, which is negative 2, less than or equal to 6 over 2 is 3, so I'll have 3 times 4x minus 3. And then 6 times 1/3 is 2. So then we will have negative 2 less than or equal to, now distributing in the 3, we have 12x minus 9 less than or equal to 2. Now we'll have to add 9 to all parts of this so we can isolate that 12x. So we'll have 7 less than or equal to 12x less than or equal to 11. And finally, we'll divide everything by 12 to isolate the x. And we will get our solution, right? So 7 over 12 less than or equal to x less than or equal to 11 over 12. And now at this point, you see, I've been graphing them all along, but can you see what the interval solution should be here? What is it? Well, we're including 7 over 12 and 11 over 12. So those are going to give us square brackets. And that's it. Okay. Now if we can graph it real quick. It's not too bad. Let me just draw that in. So 7 over 12 and 11 over 12. Right, and then you'd be all the x values in between. But I think we can jump to this, especially when we have the compound and, it's a little bit easier actually.